Well, good morning, everybody, and welcome to the first of three webinars today from Smart Vision Europe. My name's Jarlath Quinn. We're going to be starting off today doing an overview effectively of IBM SPSS statistics. This is a webinar we've run many times in the past, and you'll see recordings of, but we're doing a live demo today. If you haven't joined any of these sessions before, and I know that some of you have, you should be aware that we record them, so you'll be able to listen to them again afterwards. We'll send out a link to you and you'll be able to listen to that recording. You also see some slideware here, not a great deal, but we'll also email out a link to you so you can download the slides after the session is ended. Now, if you find that it's particularly useful for colleagues who were unable to attend today and you can get enough of them together, it may be possible for us to arrange a rerun of the session. The best thing to do is just send us an email and we'll see if we can arrange that. And with regard to asking questions, all the lines are muted. So we ask you to use the chat panel and we'll try and keep abreast of that as we're going along. If we run out of time, we'll follow up a few offline. We are used to people sending us emailing us questions after the session's ended. So again, don't be afraid to do that. I'm joined online by my colleague Rachel. Rachel will be fielding a lot of the questions as I'm speaking and as we're going along. So again, bear that in mind. Now, if you don't know who Smart Vision Europe are, we're a technology provider and we are a partner, a gold accredited partner, in fact, IBM, as well as a company called Predictive Solutions and Data Robot. And we specialize in statistics and advanced analytics and AI analytics and big data technologies and data science and all that kind of stuff. We do work with open source technologies as well, such as R and Python and Spark. And we're a relatively small organization with very deep experience. So the team itself has a range of experience from 15 to 35 years, I would say, of working in the advanced analytics and predictive analytics industry, particularly in the software and technology side of it. Most of us have worked for SPSS in the past, so we're very familiar with that. I've worked for SPSS and SAS and IBM as a consultant. And that basically means that we've got a lot of experience of applying tools like SPSS, I guess, across many different sectors, both for profit, not for profit, and also across many different applications within those sectors, whether they be, retail applications or insurance applications or healthcare or telecommunications or media or online marketing or so forth. So we can probably speak to the application, particularly of SPSS statistics and how it is used within all of these different arenas in a lot of detail and give a lot of examples. Today, however, we're really just focusing, starting off today, trying to get people orientated and trying to helping them get their heads around how to get the best out of the package called SPSS Statistics, to give them kind of an overview of what they can expect from it, and to sort of go from roughly from A to Z in the sense that we're going to start with raw data, getting some raw data into SPSS and showing you how you can format that and how SPSS wants you, if you like, to try to, set that data up. It's a very important aspect of it, and I would say that it's one of the areas where people who are new to the software and new to the technology tend to struggle. They don't really know how SPSS likes its data formatted, and it then causes problems down the line. And then we're going to talk about, doing some basic analytics and also manipulating the data and interacting with it, such as creating filters within the data so you can zero in and focus on certain groups or certain parts of the data set, as well as playing around with the fields within the data, such as creating a banded field from, say, a variable like age or something like that. We'll look briefly at the SPSS custom tables functionality. That's really just to introduce that. It's probably one of the most common and the most popular modules of SPSS, and it just helps people understand, how that is applied. Gives them a little flavor of that. We'll also look at finding statistically significant differences in groups. We'll be looking at this in more detail later on today when we look at focus specifically on statistical significance and what that means. We're spending an entire webinar just focused on that. So if this is of interest to you, we would urge you to maybe sign up for that webinar as well. It'll be very much a natural follow-on from this one. So first of all, let's start with talking about IBM SPSS statistics and giving you a kind of an overview of it. It's one of the world's oldest software packages. It's been around since 1968. Indeed, SPSS, I think, was the oldest software company. And rather like something like Excel, Microsoft Excel, it's very difficult to talk about a typical user of SPSS statistics these days. I guess it might be a student because it's taught a lot in universities. It's almost sort of ubiquitous across universities, so that's where people often encounter it for the first time. But in the professional world, in the postgraduate world, it could be used from anything from epidemiology and healthcare research. A lot of its use in market research and survey analysis. A lot of applications in marketing and business type reporting, direct marketing, credit risk and finance, process modeling in manufacturing and asset management, and predictive maintenance and things like that in utilities. But even then, that's only a relatively small proportion of the range of different sectors and applications where it's applied. It really is a very, very broad set of applications. So what you'll find is that when you open up a copy of SPSS, if you just had like a really basic installation of SPSS, what we call a base install, you would find that just within that basic installation, you would get pretty much most of the sort of statistics that people would expect to see in a statistical analysis package. You would see a lot of descriptive statistics, you see a lot of tabulation. You'd see frequency tables and descriptives, and you'd see crosstabs. The term crosstabs actually comes from SPSS. These are known as contingency tables. You'd see statistical tests, particularly classics tests like t-test and chi-square, and basic ANOVAs and correlations. You would see factor analysis. You would see linear regression and cluster analysis. You'd also see a wide range of different charting techniques, and you'd also see a lot of data manipulation capability in there, such as dealing with, uh, odd data structures which need to be manipulated, or creating new fields from existing fields, or reclassifying or filtering data, and so forth and so forth. It really is quite deep. You should be aware also that SPSS increasingly these days is informed by what we call extensions. So we do a lot of this in Smart Vision, where we actually write little applications, little tools that can be installed into SPSS statistics. You can just download them; they're a single file, and it would install a dialog box for you, which would do something very, very specific, a particular type of no, a normal distribution analysis, let's say, or a particular type of analysis for direct marketing and so forth. So you should be aware of that, that not everything that's in the base is limited to that. Now you hear me talking about the base. In fact, SPSS is a modular system. Over the years, it used to be that people would buy separate modules, or invest in different modules, which would enhance the functionality, and this would add lots of dialog boxes to the capability. I'm just listing them out here and showing you what the current sort of set of modules you can have in SPSS basis. I wouldn't worry about it too much, because what tends to happen is it tends to get sold in packages. So you get SPSS base, which is, or standard, which would be SPSS base and tables, plus regression and a few other things, or SPSS professional or SPSS premium. So it tends to get bundled up. You can find out what types of modules you have installed just by running a simple command in SPSS. You can just look that up on our website. It'll show you how to do that. But more importantly, if you wanted to find out what all the different modules are, you can look that up on our website as well. I'll show you the link to that. To give you an example of a module, this would be the IBM SPSS Decision Trees module. And this would appear as an additional dialogue in it. I only mention it because I think it's a really, really good module. And a lot of people probably doesn't get the credit that it deserves, and doesn't get the attention it deserves with people who haven't encountered decision trees before. And it's really visual. It's a way to build a predictive model. It creates profiles of customers or employees or clients or events or assets, and it finds key segments of it, and it represents data very visually. So here, for example, it's showing survival on the Titanic, and it's saying, what are the factors which drive survival on the Titanic, and it creates a sort of family tree, and it says, okay, the most important factor was gender, was actually the sex of the passenger. It says, if they were male, 21% survived, whereas if they're female, 73% survived, and then it finds subgroups within that group and splits them based on statistical significance. and says the next most important factor for males is whether or not they're adult or children, and that affects their survival rate. And then for the adult males, the next most important factor was actually the class that they were traveling in. And it's very good at finding counterintuitive little groups that you might not think exist. For example, we can see that the people with the least likelihood of survival would actually be males, adult males traveling in second class, not adult males traveling in third class. Third class, 16% survival, second class, only 8% survival. Meanwhile, over in the female branch, we don't include age because it isn't statistically significant. It doesn't make a difference whether or not you're an adult or child. It doesn't affect that group's survival. And we can see that for second class and crew, they're actually grouped together. They're grouped together because they're not different from one another. Their survival rate does not really is not significantly different. So, it finds a version of class which is more efficient and doesn't split hairs. So this type of thing is really powerful because you can use it to interpret anything where you've got some sort of key variable, like here we have survival, but it could have been satisfaction or people renewing a contract or renewing a subscription, or it could be people, making a complaint or something like that, and you want to build a profile of that. So this would be an example of a module. If you want to find out about the other modules in SPSS, we've got on our website a lot of videos. We've got a YouTube channel of lots and lots of videos of webinars like this. You can go on to our website and you can simply click on the names of the modules, and it'll give you a little 2-minute overview, just a really short overview, which will tell you what's in direct marketing, what's in missing values, what's in neural networks, what's in regression, and so forth. And it's quite informative for a lot of people. Okay, before we get into the demo, let's just talk about how people who use tools like SPSS statistics use them and what makes a really good user of these types of tools. So these days, there's just a huge plethora of tools and packages and online capabilities and platforms out there which do analytics and do statistics and machine learning and data science and all that type of stuff. No matter which platform you're working with, the people who are good at using this sort of application are people who can demonstrate skills in three areas. They have to be good at reading and formatting data. That means they have to be good at getting the data into that package, being able to load it or import it, and being able to change it or format it in a way that that particular package likes. That's a key skill. If you can't do that, you'll struggle. The next thing they need to be able to do is need to be able to transform and manipulate the data. So they need to be able to, for example, create a filter. So they say, I'm only interested in people who are aged over 34 and living in this region. I want to focus my analysis on that, or I want to compute the ratio of one variable to another. Let's say income to the number of children that somebody has. So we can, calculate some sort of disposable income. And they need to be able to do analysis, of course. They need to know, this is a good form of analysis to use for this combination of fields that I'm interested in, the combination of factors. And I want to be able to do something with the results. I might want to export them to PDF, or I might want to create new data, which shows, predictions or forecasts, or shows classifications or categories or some sort of measure that we're creating. And I want to be able to send that somewhere. So these are three key areas, and in any sort of intro to a course like SPSS statistics, you would expect that introductory course, to touch on each of these three areas so that people can go away from that knowing at least something about how to get the data in, how to manipulate it, and how to analyze it. And that's what we're going to do in the next 45 minutes or so. Okay, so with that in mind, let's take a closer look at SPSS. When we jump out to SPSS, we're going to see this sort of spreadsheet type interface. And I think that's one of the things that traditionally people have got very confused over. This is called the data editor window. In fact, SPSS opens multiple windows, two key ones, which is the data editor and the output window, the output viewer, which shows the results. But the key here is not to think that this is like a spreadsheet. It's not like a spreadsheet. There's no formula up here. We do manipulation. This is a raw a table view of a data set. So it's simply a way you can edit data within here. Most people don't interact with it that directly. the way you would with an Excel spreadsheet. You tend to, if you want to change the data, you tend to use a procedure. And then we can see across the top here, we've just got typical menus. You've got file, edit. You got stuff like edit data and transform. When you're doing analysis, pretty much everything's onto the analyze menu, and charts, everything's onto the graphs menu. So the key ones are file, transform, data, analyze, and graphs. I would say those are the kind of three or four key menus. So I'm going to start off and I'm going to import some data. That's going to be my step one, if you like. And I need to bear in mind that my data may not be in SPSS format. It might be in a different format. And one way in which I could do this is I could go to File, Import Data, and I could say I want to read a database. So I'm going to read in data from database. The best thing to do is click New Query here. When you click New Query, it opens up this database wizard. So it's going to take you through a little wizard to import data. You should bear in mind that this button here, Add ODBC Data Source, this is actually takes you to a component within Windows. It's not SPSS. When I click on that, it opens up a place in Windows, and Windows is a place where I can define a connection to to a database. So, for example, I've got one here called main, and it actually connects to SQL Server. So, you might these days people have databases online, they have databases, local databases, they might just have MS Access, something like that, if they want to connect to it. The key here is I've got a little access database here called Employee Access, and I'm just going to click on that, and that links to an access table. There's only one single table in this database to make it easy. If I drag that across, it shows me the fields in that database, and I can import that as a single data set. At this stage, as I'm going through the wizard, it's saying you can limit the retrieved cases. I can build an expression in here. This is really using SQL if I wanted to do that. The reason why it has this is simply because very often when you're talking to a database, you might be talking to a database with tens of millions of records within it, and therefore you might want to, sample or take a subsample of the data. So hence the ability to define a SQL expression here that does that. In this case, we don't care about that, so we're just going to hit next. It's showing you what the field names are going to be called. In SPSS, field names are called variables. It's telling me what the field type will be, whether it be character, string, date, or numeric. Again, not important. I just next hit finish. It's showing me what that will look like as an SQL query, which is just a really basic SQL query. Again, I don't care about that. I hit finish, and it goes off and reads the data in. This is what the raw data looks like. So that's one way in which I could get raw data into SPSS. Another very common format that data is read in or stored in would be CSV or Excel. If I wanted to read an Excel file, very similar, I'd go to File, maybe Import Data, and go down to Excel. So here, if I went to Excel, and there's an Excel workbook. I can click Open at that point. And you can see that I'm just going to overwrite this data set that's already open at this stage. And you can see here it's a little bit different. It's showing me a little preview of the data set. This is what it looks like before I read it in to Excel. So I can see that, if the fields are in the first row of data, because it says I'm going to assume that the field names are in the first row of data, the variable names in the first row of data. And if they are, then it's going to read them correctly. If they're in the third row or something like that, because maybe it's got a title, I can change it here. I can tell it to ignore any hidden rows or columns which you might get in the Excel workbook. And I can say if there's any hidden spaces here on, say, these string fields like M or F, sometimes you get spaces before or after, and they're just kind of secret, they're just kind of hidden there. You can't see them. You can say if you see any trailing spaces or leading spaces, just strip them out for me, get rid of them, because otherwise I won't be able to see those as characters in the data. I click OK at that point. It says, do you want to save this current data set you've got open? I'll say, no, I don't care about that. Hit no. And again, it reads in another raw data set. It's just overwritten the previous data set. Now, you may notice in the background here, we've got a separate window that's open. This is called the Output Viewer window. It's giving me warnings here, but the warnings are really not important. I can double click on these little icons and see what the warning is. And it's just saying, look, you're replacing the existing data set. That's all it is. So we know that. We're not terribly interested in that. If I want to go back to the data, I just go to Window and call up the data, or I click on this little orange star button, takes me back to the data. And now we are back in the data. In this stage, really, let's assume I'm happy with this and I want to actually format the data. I want to do something to it to format it. Well, the first thing you notice is things like gender here, a variable called gender. And it's all squished together. so we can't really see it. That's because it's only got one character length. So it's set the width, the column width of the table. The display width is only cosmetic here to the same width of the number of characters, and I can just make that wider. In fact, I wrote a little tool, what's called a syntax job. SPSS allows you to write its own sort of native code. I wrote a little tool and I put it on the data set on our website for people to download and install themselves because it's very often when you read in raw data, it kind of comes in. You'll get stuff like this. It looks really messy when you call it in. And you can change these widths because you can go here to variable view. This is where we go to the formatting window and we can change all the properties of the columns. And we can go over here to where it says columns and we can say, okay, I'm going to change the column width of that to like 10. And that will just change the display width. And you could copy and paste these. You could copy and paste them down and paste them in if you wanted to and say, okay, I'll paste that down to 11. Again, it can still be a bit tedious. So I wrote a little tool here. If you just click on this button here, it just auto fits it. Oh, hang on. It says I can't start it because I've got it in. I haven't. It's no longer in temp. I've got rid of it. Sorry. I've deleted it. I do beg your pardon. I've deleted it. But basically, it's a little syntax job. It's somewhere on my hard drive. I'll go and find it later. But basically, it just basically sets all these to the right sort of size. And it's as I say, it's not that onerous if you haven't got that many fields to work with. But if that's a thing that's a problem for you, just go onto our website and download that little syntax job. You can set it up so it's a button and you can click on it. But I've cleaned out the temp folder and I put it in the temp folder, so that's why it's not finding it. I'll need to reset it later on. In the meantime, we have got stuff here that we can still do to format this particular data set here because, for example, if I right click on any one of these columns, I can do some really basic sort of analysis. So, for example, if I right click here on gender and do descriptive statistics, it just does a basic analysis for me. It just gives me like a frequency table here. You can see it says gender and F&M. Well, that's fine, but you probably wouldn't put that into a report because, it just says gender F&M and, it should really say, gender of employee or sex of employee or something like that because that's what this data set was originally for. It was used in a equal opportunities court case back in the 1980s for a US Chicago bank, and it's a really good data set to work with. I use it a lot. You'll see me using it repeatedly in different webinars because it's one that everybody understands. Everybody understands that these are all different employees. Everybody understands what these fields mean. That you've got their job category, you've got their beginning salary and their current salary, and how long they've been employed. And it's got a really nice mix of field types in here, so I can do lots of different things. I can look at the correlations, and I can look at significant differences between groups, and I can do predictive models and that sort of stuff. So it's a really good one to test things out on. And if I want to demonstrate, for example, formatting a field here, I can double click. What I tend to do is I tend to double click on the header, and that jumps me to that particular field in the variable view. And I can give this field a label. So I can say this is actually this field should be called sex of employee. And because it was M and F, I can give it what are called value labels. These are little labels, little flags for the codes. And if I remember here, it was F and M, so I could say female is F. I think that's obvious, and M is male. So you can see I'm formatting the data here. Now if I right click on this header, I can still do the same thing as I did last time and do descriptive statistics again. And look, it produces another table for me. You can see it doesn't delete or overwrite the existing table. It just adds a new table onto it. And now instead of saying gender and F and M, it says sex of employee, female and male. So that's useful. And that's particularly useful, of course, when we get to fields like this one, job cat here. You can see job cat's got decimal places. And if I right click on it, it just says 1, 2, and 3. We don't know what these mean. That's absolutely non-informative for me. So I could double click on that and go and say this is actually employee category, something like that, or employee job category. And I can give it values. And the values I happen to know from many years of working with this is one for clerical, because these were clerical workers. These were the people who actually brought the action against the bank for discrimination or for unfair pay practices. The second group are called custodial workers, so the facilities, if you like. And the third group are the managers, so they're kind of manager or management. That's fine. I don't need decimal places of this, so you can see it's got two decimal places, so I can just get rid of that. And now if I right click on this and do descriptive statistics, you can see it says clerical custodial manager. So this is how I would format the data. And if for whatever reason I had a value in here, like this first value here is manager, if it was missing, if it was, you can see that for a number field, for a field using numbers, as this field uses numbers, like I can switch off the value labels. You can see the codes. If there's a null value in there, it calls it a system missing value. It applies that as missing, and what that means is that it doesn't form part of what's called the valid percent group here. The valid percent is slightly different from percent. So valid percent means for the valid data, for the data where we know if the data was if the values were there or not. Percent includes missing data, and there's different ways in which data can become missing. So, for example, we might have a code like -9 in there. Why would you have a code like -9? Well, code like -9 might just mean unknown. It might be a special category. You get this a lot in surveys where somebody is refused or don't know or not applicable or something like that to that question. So they're given a special code. And if I run that now, you can see that -9 just sticks out on its own. It doesn't know what to do with it. But if I go and double click on it and say -9 is actually a missing value and then run it again, you can see now it says missing -9. And I can even give -9 its own value label and say that that is category 4. And that's it's pending because we don't actually know what they're, we haven't got the data yet. So that'd be descriptive. Now it would say, no, oh, sorry, now it would say, wrong one. Now it would say descriptive statistics. It would say, oh, -9. Sorry, I've done the wrong one here. Clerical. Yeah, sorry, it wasn't 4, it was -9. Beg your pardon. Pending. Right click. Why is it doing that? Values -9 pending. Let me just make sure. Nominal. Oh, there it is. Sorry, pending. I'm just clicking the wrong one. I think there's one occurrence of pending there. So look, I'm just introducing you to the concept that there are lots of properties that one can attach to this. For example, you've got ID here. It's got decimal places. You don't need decimal places, and obviously you're not going to want to watch me go through this and format every single one of these fields here. So there's different ways in which you can format it. You've got this variable view here where you can copy and paste labels. You've got something called data here, define properties. That's like a dialog box. It helps me, define the properties of a bunch of variables and attach labels to them, and variable labels, and tell it what the width is, tell it what the decimal places is, and how it should be formatted, whether it's numeric or string. And I can copy properties from one variable to another variable, and so forth and so forth. It turns out actually there's a procedure here. If I go copy data properties, this procedure here is basically for situations where you've already formatted the data one time in the past, and you're opening up a new version of the data, maybe the more recent data. So, for example, if you were importing data on a regular basis, let's say on a quarterly basis from a spreadsheet or a database, you don't want to be formatting it every single time if the field names are exactly the same. So you can use the first time you formatted it as a kind of template, and you can point it to another data set. And I've got a data set here called employee just the variables, meaning it's just got the formatting. Should be employee just the formatting. And if I hit next in here and say, look, it matches it by field names. It's looking for field names that matches across and says matching active in the active data set from the source data set. And I can go through this and tell it what properties I wanted to copy across or merge of existing properties if I've already got existing properties. Eventually, I just hit finish. So a wizard, you can see instantly it just formats it. Now this one here, I had set as 1, so and I didn't have I don't think that I have any properties associated. So Yeah, we had this one's value label. So I'd set as one, so I've set that back. I'd set it -9, so I set it back to one, or set it back. I think it was a manager. This person wasn't it? Wasn't it? They were a manager, so put back the manager, and so forth, so forth. So there you can see now we've instantly formatted the data set. So we've basically got this data set to work with, and well, what have we done there? We've imported some data. We've explored some aspects of the formatting, like attaching labels. We looked at missing values there. We've looked at even things like column widths and how we can play around with the width of the column, try to get the data, all neatly set up. And once you were happy with that, you'd probably go save as and give it a name, And SPSS data files are given the extension .sav to show that they're SPSS save files. The output window over here in the background is a different type of file. It's called an SPV file, an SPSS output viewer. You can either delete these things in here, you can actually just get rid of them, just go to the top, the root, delete it, or you can just shut it down and get rid of it in the background. It won't close the data set. If I close the data set, the whole thing would shut down and would be closing SPSS. But at this stage, I could actually do some analysis at this stage, and there's different. You see me doing some really kind of quick and dirty analysis where I just right click on stuff. As you can see here, for example, if I right click on current salary, it gives me summary statistics because it knows that that variable has been formatted to be a number variable, which is called a scale field. And it's shown here as a scale field, meaning that it's not a series of categories, it's a series of numbers. And therefore, when you ask it to take a summary of that, it should show you things like the mean and the median, the standard deviation, the minimum salary and the maximum salary. Whereas here we have a category field. So when I right click on that, it should go show me percentages, which is what it does. It says this is percentage of people in this group and percentage of people in that group. And it's just doing that automatically. Now, what it's doing in the background is actually running this procedure. It's actually going down to descriptive statistics and running frequencies. And it's just running a frequencies command for us in the background, and it's changing the options and frequencies so that they are appropriate for that field. So I could say, look, show me frequencies for sex of respondent, employee category. I could put all these category variables in there. And I could even ask for some charts and say, yeah, show me as a bunch of bar charts in there. I could ask for some basic statistics like, what's the most commonly occurring value, which would be the mode. Not terribly interesting in this case. And you can play around with the formatting a bit. There isn't a lot of control here over the formatting. These are called these kind of system analysis tables. They don't give you a lot of control over what appears in the table. They give you a little bit of control over the extra statistics, but I couldn't change the labeling or anything like that. If I click on that, you can see it just squirts out all these tables for me. Shows me a bunch of charts at the bottom. But I can't switch off the percent and valid percent. To do that, I would need to go to custom tables, and we'll come to that in a second. So that's one way in which I can summarize data. Another way is to use something like crosstabs. So I went over here to crosstabs and I want to look at the relationship between variables. I might go to descriptive statistics and down to crosstabs. You can see there's a lot of different procedures in here. These ones here, for these little plus signs, are kind of these extensions that I've said added. You sort of added in additional sort of little custom procedures that people can add in. So they're kind of like using external language like R and Python and things like that to run them, but they work perfectly fine. If I do crosstabs, I can say I'm really interested in the relationship between employment category here, let's say, and sex of employee. Now I'm putting one into the rows and one into the columns. It really doesn't matter which way around it goes. There's only aesthetic differences. If I click OK on that, I get this table out. Look, let's just show me a little matrix here. It's quite hard to compare these groups, though. This is just the frequency counts. It's hard to compare them because, they're different group sizes. So what we might do is we might rerun that procedure and go to Analyze, down to Descriptive Statistics, and crosstabs again. And when I call it up again, you notice it's still got the same settings as before. So it doesn't start again from scratch because it expects you to work in an iterative way. So I go into cells here. That refers to the little boxes that the values appear within the crosstab. I could ask for row percentages and click continue. And now I've got a bigger table. It's saying 56.9% of those in the clerical group are female workers, are female. Only 43% are male. Of the custodial, there are no females, zero. 100% of all 27 custodial workers are male. And for managers, only 11.9% are female, 88% are male. So I'm comparing one against the other because I'm looking at the row percent here. If I looked at the column percent, it would tell me what percentage of females were clericals, which is not the same, of course, as the what percentage of clericals are female. So this is a really simple analysis that we can do, but very powerful analysis. Crosstab is very powerful because we can look at lots of different types of relationships within the data here. For example, if I wanted to look at the same relationship here of a sex employee and include a field like a minority classification, it will actually produce the same table as before, plus a table for minority classification. So it's going to produce one for employee against sex, an employee category against sex, and employee category against minority. So it would run it again. Now we've got two tables. Look, this minority classification. 75.8% of those who are clerical workers are not ethnic minorities, 24% are. 48% of those who are custodial workers are an ethnic minority group, and only 4.8% of those who are managers are an ethnic minority group. At this stage, we might be asking questions about, whether or not these differences are statistically significant. Well, we'll get on to that in a moment. Let's say I wanted to look at a relationship here like uh, uh, the relationship between employee category and, let's say, salary or beginning salary, starting salary, something like that. That wouldn't really work as a crosstab because this isn't a set of categories. This is a set of individual salaries. And if I run that, it's going to create this crazy table that looks like that. Because this is not employee category. This is not, sorry, salary band or salary group. This is salary individual score. So typically, when we're trying to look at the relationship between one of these variables, a scale variable and a category variable, we would normally use something like compare means, do comparison of means, and we'd do something like current salary and beginning salary, so you can put them all in here, broken down by employment category. If I click OK at that point, it gives me a table of means. You can see the mean salary for clerical workers, 27,000. Mean salary for custodial, $30,000, $30,938. And for managers, $63,000. And in fact, you can play around with these tables. In fact, any table in SPSS, you can play around with the orientation of where everything appears by double clicking on them. They're called pivot tables. And you can move the categories around. You can say, I want to put statistics up up into the columns. And then some people find that easier to look at. So you can see now I'm comparing the mean, the number of cases, and the standard deviation. Or I could put statistics into the layer control here, and I could just look at the means versus the number of cases versus the standard deviation. Within the means table itself, we should look at that procedure. You can see here that rather than going back to compare means every time, I'm actually using this little button, which is called the dialog recall button. It just calls up the most recent 12 dialog boxes I've used. So it just gets me quickly back to the means procedure. And I can go into options here and I can say, look, I'm not really interested in standard deviation, but I am interested in things like the minimum maximum. So I can add them in. So it gives me a lot of extra statistics I can add in there. But let's say for whatever reason, I did actually want to do a crosstab of salary or beginning salary against job category. How would I do that? Well, one thing I could do is I could transform use the transform procedure here to create a new version of beginning salary. And that's called visual binning. If I click on visual binning, it's pretty obvious what that's doing. If I pick beginning salary here, it actually draws a picture. It scans data and draws a histogram of beginning salary. And that's just it's like a bar chart, but it's a bar chart where it's automatically created little ranges for the histogram. So it's showing me the distribution. You can see that some people started on a really big beginning salary, probably managers. So the distribution is tailed out here. And I'm going to call this new field that I'm going to create from this. I'm going to call it sal beg begin grouped. Okay. You can see it says beginning salary binned. It's expecting me to create a new field. I'm going to call that binned. I'm going to call it banded or something like that. Now, what am I doing? Well, what I'm going to do is get it to slice this like it was a cake. And I can do that by clicking on Make Cut Points, and I can say cut it into four groups for me by saying, oh, actually, I want to click here. Four groups for me by asking it to put in three cut points. Three cut points will give me a width of 25% in each group, and hit apply at that point. And you can see it's immediately put these little bands, and I can move them around. Look at this, 25% in each group. Now, the issue here is that it's picked some quite odd threshold points here. So I could actually change these. I could say that 12,450 is a weird place. I'm not really that bothered about trying to get exactly 25% in each group. I just want to get roughly equal. So I'll just change that to 12,000 rather than 12,450. And this line here will move slightly to take account of that because they're dynamically linked to one another. So I can move the line and change the numbers, or I can change the numbers and move the line. Here's 17,490. Let's round that up to 18,000. Let's just make it 18,000 because it's more round number. Because we're not that bothered, but $18,000. And when we can ask it to make labels for each of these groups, it's going to create a series of groups, 1, 2, 3, and 4. And we can say make labels for those groups. And it immediately adds these labels to us. Look at that, less than or equal to $12,000. And I could say, I could change this to up to 12,000. We'll assume it means up to 12,000 inclusive of 12,000. And this here is 18,001 plus. Well, that's an ugly label, so I'll just change this to over 18,000. If I click OK at that point, it says I'm going to create a new field for you. It creates a new field for me. There it is. It's been added to the end. If I right click on that and ask it for descriptive statistics, it's going to give me a little frequency table. And the frequency table here is showing me that, it's not exactly 25%, but 23.8% are up to 12,000, 32% are 12,000 to 15,000, 22% are 15,000 to 18,000, and 22% are 18,000 and over. So the largest groups is sort of second group here. And if I went back to crosstabs I did earlier on, I could then look at employment category against beginning salary. If I look at that now of course I've got this. What percentage of people in clerical workers were up to 12,000? What percentage of people in clerical workers were 12,000, 15,000? What percentage were over 18,000? I can interact with these tables. I can make them a little bit wider, so I can change the appearance of them. In fact, I can right click on them because the table appearance can be formatted, and you go to table looks. You can create your own table looks and change different table looks, change them as you appear. Say, you can create your own table looks and say, and you can set them up as default so you have your own house style. You can download table looks, some additional ones that we've created in our from our website. And you'll see YouTube videos about how to create your own table looks. So this is what this is what it looks like. It says 95% of managers, not surprisingly, are over 18,000. And at this stage, you might be saying, is this statistically significant, the differences here? Well, I can absolutely guarantee they are. I'm going to change this a little bit. I'm going to change this from employment category. I'm going to change this to sex of employee. And I'm going to ask for it to run a statistical significance test for me. And the test I'm going to ask it to run is chi-square. Now, if you want to know more about the chi-square test, we'll be looking at more detail later on when we look at significance testing, our webinar significance testing today. But suffice to say that it's running a statistical test. And the statistical test is showing us the probability of getting a result as extreme as the one we've observed, assuming that there is no relationship between gender and beginning salary. So it's almost saying in a universe where gender makes no difference to your starting salary whatsoever, how often would you see a difference as big as the ones we're observing here? And the ones we're observing here are some quite big differences because we can see that females are 49, nearly half of them earn up to $12,000, whereas for males, only 2.3% of them earn up to 12,000. For females, 6% of them earn over 18,000, where for males, 35%. And it's telling us the likelihood of getting that. Well, the likelihood is really small because it's given this probability value here, which is so small it can't display it all. If I double click on it, it's actually 37 decimal places back from this point here. So it'd be 0.00037 times to a very small number. So, in percentage terms, that's a very, very small number. And of course, With significance tests, what people tend to choose is they choose a threshold value, usually zero point zero 0.05. If the number is less than zero point zero 0.05, they tend to say it's statistically significant. In this case, it's a lot less than zero point zero 0.05. Sometimes people say zero point zero 0.01, but it's a lot less than zero point zero 0.05. So in this case, we would reject the null hypothesis because our null hypothesis here is that gender is in no way related to beginning salary, and beginning salary is in no way related to gender. We're not saying one is causal or anything like that. We're saying one's different from the other. So we would be rejecting that null hypothesis on that occasion. So this would be our example of doing a significance test. You should bear in mind you can double click on these and right click on them and just click on it and say, what's this? And it says, it tells you, it says it's a significance level based on the asymptotic, that means estimated distribution of a test statistic. Typically, a value of less than zero point zero 0.05 is considered significant. And it's assumed that the data set is sufficiently large. In this case, the data set, we've got some quite small numbers here, 6 people in one of the cells, but it's pretty large. So we're fairly we're fairly safe with regard to making these conclusions here. Now, if somebody came along and said, "Look, that's all very interesting. We're looking at the relationship here between, gender and beginning salary, but what I'm really interested in is just the clerical workers versus the managers. That's what I'm really interested in. I don't want to include this other group in here who are the custodial. I know there's not very many of custodial workers in there, 27, but they do affect, this crosstab and they do affect our statistics. Now, I'd prefer if they weren't part of the analysis because I'm really focusing on that. That would require us to filter them out. And to filter them out, we would go to data here and we go into select cases. We click if condition. We'd create an if condition. We'd say if this is true, we'd say if employment category, and this is the variable job cat here. I guess we'd say something like is not equal to because we want to get rid of them. So select them if it's not equal to. And we can't remember what the code is for custodial workers. We right click on it and look at and call up the variable information window here, and we can see that code 2 is custodial workers. So I'd say if it's not equal to code 2, click continue and OK. And it looks like nothing's happened, but actually, if you scroll down very subtly, you start to see these little strokes appear through the case headers. And you see this field occurring here, which indicates whether or not somebody was selected or weren't not selected, whether or not they're part of the filter. And you can check, you can right click and look at JobCat and just do descriptive statistics. And if it's worked, you can see that, of course, we only see clerical workers and managers. The custodial workers have gone now. They're not part of the analysis. And I could rerun my crosstab from earlier and click OK. And it's still statistically significant, but now we're looking at a smaller number of cases, 448. It makes no difference to our analysis. The custodial workers are simply not part of this analysis because they've been taken out, whereas previously we can see we had 475. So we've got a smaller number. The 27 records have been removed at this stage, and they'll stay removed until we switch that filter off. And to switch the filter off, we'd go to data, select cases, select all cases, and we click OK. You notice down here it says filter on, just in the corner. If we click OK at that point, coming back to the data set, filter on disappears. So we're back to not switching. We don't need this variable anymore unless we were going to switch the filter on again on a regular basis. But that variable has been created for us. It's just a marker indicating which fields were filtered and which weren't. So I can delete that. Now, I did mention that with crosstabs and frequency tables and things like that, there's kind of a limited amount of control that one has over the formatting. So we have a module here that we can use. So this most common module, which is the tables module. And the tables module is sometimes called the custom tables module. If you click on that, some people find it more intuitive. And it allows you to mix different variable types together. So for example, I could pick up employment category here, put it across. It shows me a preview of them. Look, I can see clerical custodial manager here. And I could pick up, say, sex of employee, and I could put that as a subgroup. That's called stacking, putting it on the end here. And I could look at that against minority classification, or I could say I want to look at current salary across here. Look, it's taking average current salary. beginning salary and taking that. Look, beginning salary. I could look at education level. Okay. And I could say I don't like average as a summary statistic. I'm actually really interested in here. The people who want me to analyze this want to look at the median. Um, and there's lots of other statistics we could add in here and say apply that to everybody. And then I want a sort of overall average. So I'm going to put a total in here. I'll change this total to overall. All right. And again, I don't want the custodial workers, so I could click over here and say tick out the custodial workers. See, I've got a lot more control over here. And click apply and click OK. And it runs that. Now we've got the median values here. So I could say, oh, actually, I've done this wrong. What I wanted was employees as a subgroup of the and sex as a subgroup of these groups. So yeah, I can make it a subgroup just by moving it. That's called creating a nested variable. I could say we don't need the label sex of an employee here because it's pretty obvious what it's referring to. And so I could right click on that and say switch off that label and click OK. And now the label switched off and we get this different table and so forth, so forth. So you can create really quite complex tables where you're mixing, I could put in minority classification on here at the end and, I could have the count of minority classification, or I could say I want, column percents or something like that added in. You can create quite complicated tables and you can change the formatting of them and change the labeling for them, etc., etc. So it gives you an idea worth playing around with. So creating more and more complex data tables, a way for us to kind of do crosstabs and frequencies and descriptive statistics and mix them all together and have a lot more control over the formatting and the appearance of the tables. And that's really what custom tables is for. It's purely for tabulation and part of the tabulation tools that one would use. Okay, there's a few other things here I wanted to point out to you before we finish up today. The first thing is that pretty much everything we're doing can be recorded, and this is very important, even if you're not somebody who does coding or anything like that. So, for example, if I went to my crosstabs procedure here on, I could rerun that. I can just rerun it. What's really happening in the background, if I call it up, is it's running SPSS syntax. So SPSS is older than Windows. And used to be back in the day when SPSS was first written in 1968, people wrote code. And the code was specifically designed to make it easy for people to write. So it was sort of plain English. So if I hit paste here, it shows me the code. Now that data set activate is just a thing that sticks at the start saying, because you might have more than one data set open that's saying I'm working on this data set. So I can get rid of that. But you can see it says the command here is just crosstabs, tables, gender by beginning salary grouped. That's names of the field. These are the column headers in the field. And then the rest is just options that it's sticking in. You could actually, I think you can usually, I used to do this a lot back in my early 20s. You can see that you can just type this and it starts, it's starting to complete it for you. Crosstabs. And I could say, look, I think there's a variable there called minority by, let's say, emp employee category or something like that. Employee cat, I think it is something like that. Emp group, something like that. Is it emp group if I can remember? No, job cat. Sorry, that's why it wasn't showing up. Oh, let's see if I could see job cats. Let's guess it really. You could run that you could run that crosstab. It would just give you a really basic crosstab. So, you don't have to write everything out. But suffice to say, if I run just this section here, so it just means just run that selection, it just runs that for me and it recreates that. Whereas if I run the second section here, it's just going to give me a really basic crosstab I would expect. Yeah, that's just a really basic one. And you can add in additional stuff here. You could say, okay, well, look, I think the sub command for this would be /sales. So it's sales equals the count, yeah, and row, yeah, no, not residual, but row. You could run that again. So you can type this stuff away, but you can also, of course, as you saw me earlier on, you can just hit paste, just hit the paste button, and it pastes it for you, and it just adds it to you. So every time you're doing something, see this the custom tables code is really complicated because there's so many options of custom tables. But as you're going along, you can basically record everything you're doing. So if you're analyzing the same sort of data set on a regular basis, or if you want to sort of create versions of analyses, and make sure that you want to keep a record of everything you're doing as you're going along, then that's a really handy way to do it. So for example, if I just go File, New Data here, and just empty that, and I'll close down my cross syntax and close down my output and just start with absolutely nothing. Um, I would be able to open up a syntax job that I built earlier and go File, Open Syntax, because there's SPSS code and there's sample syntax. And it actually reads this ODB. It actually does this connection for me. I think this will work. The ODBC connection might be somewhat dodgy, but let's give it a go. See what happens. If I run all, it then applies a data dictionary. It does crosstabs, tables, and stuff like that. Let's just see if this first bit here runs, because if it doesn't, actually no, I'll just run the whole thing. So I'm going to say run all. We'll just see if it runs. Oh yeah, so it's read it in. It's just formatted it, and it's squirt out. Look, a whole bunch of different output here, including tables, sorry, some charts. I should just point out briefly before we end here, you can do charts. There's a little chart builder up here. It's very simple, very intuitive. You just choose a chart from a menu here, and then you populate that chart and say, I want to look at gender, say by employment category. There's lots of controls. You click OK, and it creates a little chart for you. Okay, so that gives you hopefully an overview of that. If you wanted to export the output here, I find something that, again, people don't necessarily know about, but which is really quite useful. If I click on this and say copy as a Microsoft Graphics object, and if I then go and say close out of this and just open up something like Excel, or a tool like Excel, um, it will. I could see if I can just get out here and back to my Windows. I would be able to copy and paste that. Let's just see if I can just say File, New. This is a Microsoft tool. I could say paste as. So you can see, look at paste as a Microsoft object rather than as a SPSS object. So it's something to bear in mind. You could go into this chart type here and go to chart design and choose a different chart. Look at that. Change it all for you. So something to bear in mind. You don't have to stick with the charts in SPSS. You can actually paste them out into a Microsoft compatible tool like PowerPoint or like Excel or like Word or something like that, and it will paste them as a chart for you. Okay, you should be aware that we've got a bunch of additional resources here on our website, and you'll see these links to it. You've got SPSS FAQs. We've got some video guides, how-to topics with mini demos. We've got information on products and modules and pricing, which you can buy your products directly from us. And indeed, there are lots of advantages to doing that because we can offer them with discounts. And we also offer access to our free training catalog. There's a blog series on there. To everybody, to all comers, we've just introduced our own Chat SPSS chatbot tool. So this is like it's like ChatGPT for SPSS. You could sign up for that. So if you wanted to learn how to do pretty much everything that I've shown you how to do here, and you just want to ask it, how do I create a crosstab? How do I add in chi-square test? How do I, what's the syntax? How do I write syntax to record this? Just click on this link, sign up for it, and you'll be able to interact with your own dedicated chatbot specifically for SPSS. You should be aware, of course, as a company, we've got decades of experience providing consultancy and training and guidance around statistics, not just SPSS, but around statistics and data science and analytics generally. So if you want to reach out to us for any help, would be delighted to talk to you. As I say, you can buy your analytical software directly from us. We do offer formal classroom training as well as virtual training and online self-paced training resources. And these, the online training resources are free to our customers. People who have licenses with IBM can transfer their licenses to us. We provide no strings attached technical business advice relating to analytics to everybody, irrespective of whether or not they're customers. So if you're not a customer of ours and you just want to talk to us about statistics or about analytics, just reach out to us and we'll try and give you some advice on that. And for our customers, we offer our own dedicated technical support services around IBM. So and they're tracked and they're formally supported. We do hope you found that useful. In the meantime, we look forward to you logging in again. You should be aware that we have another webinar coming up where we're looking specifically at how to clean your data in SPSS. Thanks very much for logging in, and we look forward to you logging in again.